Hello everyone, I hope you're doing well today. Today we're going to talk about factoring special products, or as some people call it, factoring special patterns. Before we jump into factoring our special products though, let's take a moment to review what our special products were. Looking at the first example, I have the quantity of x plus 5 squared. When I square something, remember it means to multiply it by itself. So I have the quantity of x plus 5 times the quantity of x plus 5. Using the double distributive property to multiply this out, I'm going to take my first term, x, and distribute it through to the second set of parentheses. X times x is x squared, and x times 5 is 5x. Then I'm going to take my second term, 5, and also distribute it through the second set of parentheses. 5 times x is 5x, and 5 times 5 is 25. I can simplify this polynomial by combining like terms, and I end up with x squared plus 10x plus 25. Now if we look, x squared is the square of our first term, and 25 is the square of our second term, 5. This middle term is twice the product of the two terms. So if I multiply 5 and x to get 5x and double it, I get 10x squared. So my special pattern or special product is if I have the quantity of a plus b squared, it is equal to a squared plus 2ab plus b squared. Looking at our second example, the two binomials are almost exactly the same. I have the quantity of 2x minus 3 times the quantity of 2x plus 3. Let's use our double distributive property to multiply these out and see what pattern we get. If I distribute through the 2x to the second set of parentheses, 2x times 2x is 4x squared, and 2x times 3 is 6x. Then if I take my second term, negative 3, and distribute it through the second set of parentheses, I get negative 6x minus 9. If you notice, the two middle terms are opposites of each other, so when I simplify it, I'm left with 4x squared minus 9. This is what's known as the difference of squares because both numbers are perfect squares. If I look, I take my first term, 2x, and square it. 2x times 2x is 4x squared. I take the second term, 3 times 3 squared, or 3 times 3 is 9, and I have subtraction in the middle of them. So my special product or my special pattern is that if I have a squared minus b squared, it means that I started out with the quantity of a plus b times the quantity of a minus b. Please take a moment to pause this video, record these two examples, and write down our two special patterns. Now, the pattern that we realized, a squared plus 2ab plus b squared is equal to the quantity of a plus b squared, can also be rewritten as a squared minus 2ab plus b squared equals the quantity of a minus b squared. Looking at the two examples we have here, starting with x squared plus 8x plus 16, we need to see if it follows one of these patterns that we have on the left. So I see x squared in the spot where a squared is, and 16 in the spot where b squared is. Well, if x squared is a squared, then that means that a is equal to x. And 16 is in the spot where b squared is, which means that b is equal to 4 because 4 times 4, or 4 squared, is 16. If I multiply a and b and double them, I do get 8x. So it works out and we have this special pattern here, which means that I can factor this using my special pattern and know that it's going to be x, the quantity of x, plus 4 squared. Looking at my second example, I notice that I have 4x squared, so in the position of a squared, and 25 in the position where b squared is. Well, if 4x squared is a squared, then that means that I'd have to multiply 2x by 2x to get 4x squared. So a is equal to 2x. And b is equal to 5 because 5 squared is 25. Now let's see if it follows the pattern. If I multiply the 2x and the 5 together, I get 10x. If I double it, I get 20x. But since this is negative 20x, it follows our second pattern, which means that my polynomial factors into 2x minus 5, and then I square that entire binomial. So there's my special pattern factored. So when we're factoring using the special pattern, we first need to identify our a and b by taking the square roots of the first and last terms, multiply those quantities together and double them to see if it fits our pattern. If it fits the pattern, then we just factor it using the pattern that we've been given. Take a moment to pause this video and record these examples. Now let's take a look at another few examples. Looking at x squared minus 4. I need to notice if I have the pattern, so our second special pattern was the difference of squares. If I notice, my first term, x squared, is a perfect square. So x times x gives me x squared, which means my a is equal to x. If I look at my second term, 4 is also a perfect square because 2 times 2 is 4. So the value of b is 2. So it does fit my special pattern because I have the difference or the subtraction of two squares. Using that, I know that I can factor using my pattern, so the quantity of x squared minus 4 would factor into x plus 2 times the quantity of x minus 2. Looking over here at the second example, 16x to the fourth. Is it a perfect square? Well, I know 4 times 4 is 16, and x squared times x squared is x to the fourth. So that is a perfect square, because 4x squared times 4x squared gives me 16x squared. Is 25 a perfect square? Yes, because 5 times 5 is 25. So now I've found my values of a and b, and I notice it is the difference because of the subtraction. So I can factor it using my special patterns. So 16x to the fourth minus 25 would factor into the quantity of 4x squared plus 5 times the quantity of 4x squared minus 5. Please take a moment to pause this video, record these examples, and any questions that you may have for when we have our next Zoom meeting. Be well, stay safe, and see you soon.